Okay, good afternoon. So let us continue the lesson. The lesson is we learned a little bit about algebraic expressions, and now the algebraic expressions are not that useful if we do not have any rules to operate on them. So for example, if I give you two algebraic expressions, I would expect you to be able to add them, multiply them. Of course, divisions are a little bit harder. You have to wait until the next lessons or courses. But for the time being, what we need to learn is that if I give you two algebraic expressions, I want to teach you how to add them, subtract them, and multiply them. And if I teach you how to multiply them, in principle, I can ask you how you can raise them to integer power, natural powers, yes? Because, for example, any number to power 3 means that expression, that number multiplied by itself 3 times. If I give you the rule for multiplication, in principle I can give you the rule for raising to positive powers as well, yes? So the operations that you should expect to see in this lesson are addition, subtraction, and multiplication, and natural powers of algebraic expressions, yes? But divisions and rational expressions, things like that, will remain for the other courses in the future. So what we know, so I told you that when I say an algebraic expression, for example, you expect something like this. For example, 2x to the power of 2 plus 3x minus 5. This is an algebraic expression which contains only one variable, and that is x. If I ask you, can you write this in a more simplified version? In this case, the answer is no. I can ask you, for example, calculate the value of this algebraic expression if x is equal to 1. So if I assign a number to my variable, then it becomes simple. What you need to do, you need to replace every x that appears in the expression with the value given, and then you see that this becomes that one. Okay, in this case, 1 to power 2 is 1 times 2 plus 3, 5 minus 5, 0. So you can simplify this expression only if I give you the value. But here you cannot simplify it more. Because if you want to simplify more, can I do this operation right away? No. Because if you want to do this addition, yes, you have to know about this and you have to know about that. So it means that first of all, you have to do this product and then add the results. But you cannot continue any further because x is not given to you. But sometimes, actually, if you have 2x and 3x, here I can simplify it more. Even though in this case I haven't given you the value of x either, but you can write something in front of it in a more compact form. And that is the topic of today's lesson, to simplify algebraic expressions as much as possible. Yes? So that is the goal. So what can I write in front of 2x plus 3x? So you can imagine x is whatever you have. You don't know the exact value, but it doesn't matter here because 2x, it means that you have 2 of these values. 3 of the same value is added to it. So regardless of the value for x, you now know that how many of those quantities you have. You have 5 of them, so you can write 5x. So in principle, if you want to understand this, you say that I have 2x, I have 3 more x to it. So how many x's I have? I have 2 x's here, and I have 3 x's there. So, but this is so simple for you that you don't do this step. So you immediately get 5x. Okay, but might be the numbers that are sitting here are a little bit uncomfortable, so you have to do the calculations. For example, if I ask you what is 2/3 of x plus 2/5 of x. If I ask you to simplify this expression, you can still simplify that expression, but it is not as straightforward. So you have to go to a scratch paper to do some calculations, or you can write everything down in front of in the question itself. So 2/3 of x plus 2/5 of x. How many of x's are there? So you have to calculate. So how do you do that? For example, you go to a scratch work, and then you say that 2/3 of a quantity is supposed to be added to 2/5 of the same quantity. So then I want to see what is the fraction at the end. So what is the fraction? You rescale them into the common denominator. What is the common denominator between 3 and 5? 15. So you say that 15 divided by 5 5 times. I multiply 5 here. And then you say the same thing. 15 by 5 3 times. You multiply it here. And then you add them. It becomes 16 over 15. When this is done, you come back here, and the answer is what? 16 over 15x. Okay? So this is the important thing, the only thing that you need to know. But if I just write this for you, it doesn't mean it doesn't make sense. Yes, it makes perfect sense, but you cannot continue further algebraically. Because you cannot say that I have 7. Yes? Why? Because here you have 2 times of this quantity x, but then you have another quantity 5 times of another quantity, which is x squared. X and x squared are not usually the same, so we cannot say that I have 7 of x or I have 7 of x squared. Neither. I have 2x, one thing, and then I have 5x squared, another thing. I cannot continue further until I give you the value for x. Then you replace x with that value, and then you can proceed. So remember, this is not meaningless. It is meaningful, but you cannot write it more compactly. This is the final version. It's already, thank you. It's already in the simplified form. But this one, no. 2x plus 3x, you can simplify it more. And that is what I want you to learn. To write the expressions as compact as possible. So instead of 2x plus 3x, I just write simply 5x. But if I have here, I will not be able to continue further. So this is the terminology we use. We say that this term and that term are not similar. But these two terms are similar. When do I say terms are similar? If the letter part are identical. That is called similar. For example, I can have 3x squared y plus 5x squared y minus 2x squared y. So this expression, all the terms involved are similar terms. Why? Because if you look at the letter part of here, it is x squared y. The letter part here is x squared y. The letter part here is also x squared y. All of them are the same. So we say that this algebraic expression contains 3 similar terms. So can I go further? Yes, I can simplify that. How should I say that? What is the simplification? I have 3 of these quantities. I add 5 more of those quantities. So far I have 8 of them, but 2 of them I subtract. So how many is left at the end? 6. 3 plus 5, 8, minus 2, 6. So you see that this is of course the same mathematical expression, but it is written more compactly. Yes? Okay. So but you might have a mixture of expressions. For example, you can have this expression. So you can have 2x plus 5y minus 3, and then I have plus 7x plus 8y positive 10. Okay, so if I give you this and I ask you to simplify, the first thing that you have to do is to recognize which ones are similar. So you realize that 2x and 7x are similar. Yes, do you want to answer or you want? The similar terms, yes, you group the similar ones together. For example, I underline these two once meaning that these are in the same group. These are not mandatory, by the way. What I care at the end is the correct answer. So, but if this is very big, then if you are not organized, might be you get some, so you just miss one term or something. Okay, and then I would say that 5y and 8y are also similar. And -3 and 10 are just numbers, so they are also considered to be similar. So this means that if I want to simplify that, I write equality in front, and then I would say I have 2 x's here and 7 x's there. In total, I have 9 x's. Yes? And then between these two, what can I write? 13 y's, and I have -3 plus 10, which is 7. So this is the final version that I can continue. If I want to continue further, it's not possible unless I give you the values for x and y. If I don't give them, that is the end. That is the most. Of course, some of you might prioritize y over x. That's also okay. So if you write in the exam for this 13y plus 7 plus 9x, that is also okay. Because there is no difference between 9x plus 13y or in a different order. So if you write that one, it's also correct. So there is no exact unique way of writing the answer. So you can consider all of these things the correct answer. Any questions? Okay, so I don't think there is something very deep going on here. So you just group them into similar groups and then start adding them. And then, by the way, there are some names, might be it is good to know about them. If you have a term, there is a letter part and there is a numerical part. That numerical part in mathematics is called coefficient. Okay? So this is the word that we give the name, this is the name for the numerical part, which is multiplied by that letter part. That is called coefficient. And if you have a term without any coefficient, it means that coefficient is, for example, if I just write x, what is the coefficient of that? It is 1, because in principle when you say nothing, it reminds you of 0, but that is not the case. So when you see x itself, it is just 1x, which we don't bother to write 1x, we write x. And one more thing, if you see minus x, what does it mean? What is the coefficient of minus x? -1. No, the coefficient is -1 because minus x can be viewed as -1 multiplied by x. So that is also good to know. For example, if I ask you what is the coefficient, by the way, that's good practice to make sure that you know this. For example, if I write -5x squared y to the power of 2z, what is the coefficient here? -1. But if I write x 1 over 2 x squared y squared z, what is the coefficient? 1 over 2. Remember this. If I write this, what is the coefficient? I want you to know this right away because I have seen. If I write like this, what is the coefficient? No. 1 over 3. Because that is another way. Remember, I want you to make sure that you understand this. If you write A over B, it is the same thing as 1 over B times A. I want you to understand that these two things are the same. First of all, tell me why these are the same. Because if you want to multiply, because I have seen many students sometimes make mistakes, they multiply this here. No, because when you want to calculate this, the rule is to make this a fraction in your head. So this becomes A over 1. And then you multiply the numerators and then you multiply the denominators. So this becomes A times 1, B times 1. 1 times A, B times 1. But 1 times A is A, B times 1 is B. So this is why if you see 1 over B multiplied by A, that is the same thing as writing A over B. So whenever you see this, another way to write this down is what? 1 over 3 x squared y squared z. And if I ask you what the coefficient of this is, exactly as you answered here, 1/2, you immediately answer 1/3. So even if it is written in this form, I want you to understand that this is the same thing as here. Okay? Okay. Okay, so there is nothing very deep going on here. So if you want to calculate things, what you need to do is to just group them and start adding them case by case. Okay, so there are some things that I want you to understand. Sometimes we have pairs of brackets that is important. For example, you might see something like this. You might see that x2 plus 2y minus 5, and then I add plus and I put another pair of brackets here. For example, I would say that minus 3x squared minus 2y plus 10. And I ask you to simplify this expression. Simplifying this expression, it means that you have to remove pairs of brackets and then find the similar terms and combine them to make them simpler. So the rule is that if you want to remove the pair of brackets and nothing is behind that pair of brackets, you shouldn't be worried. You just remove it. So there is no difference between this way and just simply writing it like this. And even if there is a positive sign behind the pair of brackets, you just remove it, yes? So this becomes plus, but this is important to understand. If I put plus here, I want to remove this pair of brackets. So what is left? It is plus this, and then I will have again minus 2y plus 10. But plus minus is what? Minus, so we just clean it. And this would be the way that we want to do it. And then you see that this one and that one are similar. These two are also similar. And these two are also similar. So if you want to simplify them, x squared minus 3x squared is minus 2x squared. And what happens here? It is in principle 0y. But no one bothers to write 0y, because regardless of the value of y, when you multiply y by 0, the answer is 0. And when you add anything to 0, it becomes the same number itself. So in that case, you really don't bother to write it down. So you can sometimes you see that people cross them over to simplify the calculations. So these two are gone because they are exactly the same with opposite sign. And then minus 5 and 10 added together, it becomes positive 5. So this is the simplified version. But if I have a negative sign in between, I want to make sure that you understand that one as well. By everything, exactly. So that is the only point I have seen. Even I myself sometimes don't respect everything if I want to do things quickly. But remember, for this pair of brackets, I simply remove it. Yes? It becomes what? X squared plus 2y minus 5. But be careful, when I want to remove these pair of brackets, because there is a minus sign here, some students only apply this minus sign to the one closest to that minus sign. But this is not correct. This minus sign will go for this one, for that one, and for that one, okay? So this minus sign goes here, minus times minus becomes plus. This minus sign also goes there, it becomes plus, and minus sign will also go there, it becomes minus 10. And then if you see again, this one and that one are similar, these two are also similar, and these two are also similar. So if you add them, it becomes what? 4x squared plus 4y minus 15, and that's the answer. By the way, why is that? For example, if I want to convince you, so what I'm trying to say is that if I write a minus b plus c, or if I write a minus b minus c, these two are the same. You see, if I want to remove this pair of brackets, this minus sign goes in, it becomes minus b, and then it becomes plus c, which is exactly the same thing. But these are not the same thing, are they? A minus b minus c. For example, let us give numerical examples. Let me choose a to be 1, b to be 2, c to be 3. If I calculate the first number, it becomes 1 minus 2 plus 3, which is 1 minus 2 minus 1 plus 3 is 2. Let me calculate this one. It becomes 1 minus pair of brackets 2 minus 3. Which one has the priority here? This one, because pair of brackets is around that. But 2 minus 3 is how much? Minus 1. So this becomes 1 minus minus 1. But this becomes 1 plus 1, and that becomes 2, which is exactly the answer you got here. But if you mistakenly take this one for that, you will see the answer is wrong, because this becomes 1 minus 2 minus 3. 1 minus 2 is minus 1, minus 3 is minus 4, and the answers are not the same. So remember, if you have a negative sign behind a pair of brackets and you want to remove that pair of brackets, that minus sign will go in and apply. It's applied to all the terms there. Yes? Okay. So, but you see that these are not that interesting. Might be multiplication is the more exciting one in this regard. So let us just start doing that little by little. Okay, the first thing that I want to talk about here is how to multiply a number a by a sum of two numbers. Yes? So, do you remember this is a times b plus a times c. This is called distribution or distributive law. Okay, so that's distributive law. So this means that multiplication is distributive over addition. So you can take it and distribute it. You can understand it from geometrical perspective. For example, let me give you an example. Assume that you have a rectangle so that the height is a centimeters and for example, the length is b plus c centimeters. For example, assume that from here to here is b units and from here to here is c units. Yes? Yeah. If I ask you calculate the area of this rectangle, what you do? So the area is equal to, you can calculate the area in two different ways. And if you calculate the area, the same quantity in two different ways, and if you haven't made any mistakes, the answers should be the same at the end. So let us calculate the area in a normal way. In a normal way, I mean you take the height and then the length and then multiply them. The height is a and the length is how much? Okay, so it becomes a times b plus c. Do you agree that this will be the area? But you can calculate the area in a slightly different way. So what you can do, you can imagine that you draw an imaginary line from here, and then you partition the the rectangle into two parts. And then you can calculate this area, let me call it area number 1, and then you can calculate this area number 2. But in order to be able to get the total area, you have to add A1 and A2. So I would say that the area on the one hand is this number, on the other hand is the sum of these two areas, area 1 and area 2. But if I ask you what is the value for area 1, you would say that this is again a rectangle, so I will take the height and multiply it by the length of that particular rectangle. So this is A times B. Yes? And if I ask you what is the area of this rectangle, you will do the same thing. You will take the height, which exactly is the same height, but you multiply it by this length, which is c. So what is the answer? It's a times c. But because you are interested in the total area, you have to add them, so you add them. But this is, you are calculating the same quantity. What is that quantity? The total surface area, in two different ways. So if you come with two different answers, that is inconsistency. So these two numbers, we have to admit that they are the same. Okay, so a times b plus c and ab plus ac, they are exactly the same numbers. So this means that if you have a product here and you have an addition here, a sum here, you can distribute. You can take this and distribute it here and there. Yes? Okay, but distributive law, you might say that, okay, this is a little bit restricting, yes, because I have only one single term and I am going to multiply it here. What do you think about this one? So can I do the same thing for distribution law here? So if I want to do this, that is also possible. Yes? You can also see it from the geometrical perspective. Okay, one thing is to do what? If I ask you, can you tell me what is this value? You can use geometry again to answer this question. But this time, what do you think I will do? I will take a rectangle. Yes? For example, assume that this height consists of two parts. One part, say, with length A. One part, say, with length B. If I ask you what is the total height, you would say A plus B. And I will do the same thing here. Assume that this from here to here is C units, and from here to here is D units. Okay? And if I ask you what is the total length, again you will answer C plus D. So what is A plus B, C plus D? It is the height multiplied by the length, which is exactly the area. So this question mark is the total area, yes? But the total area, again, can be calculated in a slightly different way. From here, I draw a horizontal line, and from here, I draw a vertical line. The original rectangle is partitioned into 4 non-overlapping rectangles. Okay, now I have 4 areas to consider. Area number 1, area number 2, area number 3, area number 4. So if I ask you what is area number 1, you would say that this is the height and this is my width, which is exactly equal to C. So this part becomes A times C. And if I ask you what is the area 2, you would say that this one is exactly equal to this, so it is A, but from here to here is equal to from here to here, which is D. So this becomes A times D. Yes? And this here, what is the answer for this one? For the same reason, B times C. And finally, how much is this one? B times D. So this means that on the one hand, the area is this. On the other hand, the area is the sum of these 4 areas. So AC plus AD plus BC plus BD. Yes? So these two numbers should be the same. So this means that if I give you this, I do not mean at all, because we want to work with algebra. We don't want to use geometry. Of course, they are connected somehow. But here, what I want you to do, you take one term, and then you multiply it to all of them. So you distribute this one here and there. So this becomes AC plus AD. And then when it is finished, you go back and take this one and do the same thing. Yes? So this is the way that you have to distribute things. Okay? So let me start with simple examples, because that is the main thing that I want you to learn, how to multiply algebraic expressions. For example, let me start with the very simple thing. So first I start with numbers. So I would say 3x minus 5y plus 10. Then I would write plus 5, 2x minus y plus 1. We want to simplify this. Okay, what I'm supposed to do? If I want to simplify this, I want to expand this. This is another terminology we use. Expand and simplify. When I say expand, I mean continue until you do not have any pairs of brackets left. That's the meaning of expansion. Okay, what you need to do, the operation here is multiplication. The operation here is multiplication, and this one is addition. But you know that multiplication has priority over addition. So it means that you have to do this one first, this one second, and then add them. If you want to be very rigorous, the principle, what you need to do, you need to open this pair of brackets plus another pair of brackets. What should I put inside this pair of brackets? The result of this product. What should I put in this pair of brackets? The result of this product. Yes? It is not necessary for me. I want you to understand. If you can do it quicker, much better. Okay? So what I do, I will take these two and I multiply it here, here, and there. So what is the answer? 2 times 3x, 6x. 2 times minus 5y, minus 10y, and then 2 times 10 is 20. And then I keep 5, I multiply 5 in, so it is 10x minus 5y plus 5. And now the time is reached. I have to remove the pair of brackets. But this is the same story, because this is why I'm saying you really don't need to write this down for me, but you need to think in this way. So you just remove this pair of brackets. According to that rule, do I need to be worried about something? No, because there is nothing behind that. Here, I can remove it. I still don't need to be worried about anything because there is only a plus sign behind that. Yes. Yes, then that would be important. Okay, and never stop here. Be careful. Here, expansion is finished, but simplification is not. And when I say simplify, I mean expand and simplify. So these are the words that you need to respect. So again, you can do it in your head now. This one and that one are similar. These two terms are also similar. And this one is similar to that one. So you have 6x and 10x added. It becomes 16x. Minus 10y here, minus 5y is there. What's the answer? Minus 15y. And then finally I have 20 here and 5 there, which is 25. So that is also the answer. What do you think this will be like this if I have, for example, 2 x squared minus 3x plus 1 minus 3 minus 2x squared plus 6x negative 1. If I want to simplify this. Yes?
The signs, the operations inside the second bracket will change because there's a minus.
Yeah, this is acceptable for me if you write it quickly, but let me just do it patiently like this. So if you want to do it patiently, what do you have? You have an operation of multiplication here. You have an operation of multiplication here. And then you have a subtraction. But you know that multiplication has priority. So if you really want to write everything down, you have to open a pair of brackets to put the result of this operation here. You need to write minus, and then you need to open another pair of brackets to put the result of this operation here. But I would prefer myself to do it in one step, and I want you to learn to do it in one step but without any mistakes, okay? But this is the way I think about it, even if I don't write it down, okay? So I multiply 2 in, so this becomes 2x squared minus 6x plus 2, and then I multiply, be careful, minus sign I have kept here. I'm just multiplying 3 in. So this becomes minus 6x squared plus 18x minus 3. Now I remove pairs of brackets. For this one, no care is needed because there is nothing behind that. I just remove it. But for the second one, that is the previous lesson that I told you. I want to remove this pair of brackets. There is a minus sign here. Be careful. This minus sign is not just for the first one. So minus will apply here. It becomes positive. But this minus also applies for the second one and the third one. So the second one becomes negative. The third one becomes positive. I myself prefer to forego this middle one and just write this. And I think that you can do that. But make sure that you really understand and you are not messed up. Because I can give you complex examples. I have seen some students. This is not, by the way, very hard. But sometimes I have seen students get confused. Okay, so what's the answer now? So this one and that one are similar. These two are also similar. And this one and that one are also similar. So what's the answer? 8x squared minus 24x and then 5. So that is the simplified version of that one. If in the exam someone writes like this, that is also okay. Yes? They are the same thing. Be careful. But these are not the same things. If someone answered this, that is correct. But if someone answers this, that is wrong. Because here 24 comes with the positive sign. In my answer, 24 comes with a negative sign. But here that's okay, because it's still 24 is coming with a negative sign. Yes?
Can you give us a similar example, but on the level that is going to be the test?
No, but you see the levels in the book are more or less like this. So these are the ones that are being good in the exam. So what I'm saying is that try to work on the problems in the book. But let me also now try to combine problems together. Okay, one step harder is that these are not numbers. So, okay, let us try to, for example, do this together. I have x minus 1 here, and I give you x squared plus x plus 1 here. Or let me start with simpler one. So I give you x plus 1, and I give you 2x negative 5. And I ask you to multiply this, expand this. So this is this idea. So what you need to do, how many terms, how many quantity, how many polynomial algebraic expressions I have here? 2. This one and that one, I want to multiply them. So there are 2 terms involved here. I take the first one and then multiply it here and then multiply it there. Don't be in hurry, okay? So what you need to do, take x in your head, multiply it by 2x. What's the answer? Because the coefficient is 1, 1 and times 2 is 2, but of course you can write xx, but xx has a better name, which means x to the power of 2. So just do it in your head. So the answer is 2x squared. And then take x and multiply it by negative 5. What's the answer? Negative 5x. And then go here. When this is finished, now go back and take the whole thing. Remember, you have to consider the sign as well. So you take this plus 1 and multiply it here. Which is the answer? Plus 2x. And then you take this one and multiply it there. It's minus 5. Be careful, you are multiplying. Now, this is sometimes I hear that the students get confused. I'm not adding 1 to minus 5. I am multiplying all the time. Yes? But now a multiplication is finished. Then you need to know yourself that if it is possible to simplify, you have to simplify. Otherwise, you lose some parts. So then what happens? It becomes 2x squared. So what's the answer to this part? Minus 3x. If you have some doubt, please let me know. Minus 5. So that is the final answer to this problem. Yes? Let me solve another example for you. For example, let me write 2x minus 3 and let me multiply it by 4x squared plus 6x plus 9. We want to simplify this expression. So what I'm supposed to do, I will take this one and multiply it here, here, and here. So there are 3 terms. Yes? So let us just do this one. 2x, 4x squared. 2x times 4x squared. Because you know that 1, 2, 3, 4 numbers. I have 4 numbers that I want to multiply. I can multiply this to the last one, this to this one, but that's not, I want to simplify things. The best thing is to multiply 2 by 8 because I have a better name for it. Yes? And then x times x squared, I have a better name for it. I want to draw your attention to this point. By the way, this is not, so when I write 2x, 4x squared, all these operations are multiplication. And if you want to multiply 4 numbers, there is no such a strict rule that you have to multiply this one by that one. You can multiply this one to the last one. But it is not useful here because my goal is to make them simpler. Okay, so 2 times 4 is a better name. We have a better name for it, that's 8. That's why, even though we don't have to multiply 2 by 4, but in order to simplify, we do it like this. So the answer exactly is 8x to the power of 3. But then you take this one and multiply it here. Positive 2x multiplied by positive 6x is positive 12x squared. And then 2x positive, when I do not see any signs, it is positive. Multiplied by positive 9, positive 18x. And then when it is finished, I return again, take another term with its sign, and multiply it here, here, and finally there. So what's the answer? Minus 3 times this is minus 12x squared, minus 18x, minus 27. Yes? So what I have to do now, something interesting happens. You see, 12x squared is not only similar to this one, but exactly opposite. So this one, whatever it is, they cancel out. And these two, the same story. Yes? So this one and that one are also gone. So it is more simplified in this version now. It's 8x to the power of 3 minus 27. But this cannot be simplified more than that. Yes? Any questions? Okay, for example, what is your opinion if I give you this? For example, I give you x plus 1, and then I ask you to raise it to power 2. This is also some confusion. I have seen students get confused sometimes. They write x to power 2 plus 1 to power 2. Let me just write 2 for the time being, or 3 is better. So some of you might think that the correct answer is what? X to the power of 2 plus 9. But you will see that this is not the correct answer. By the way, using geometry, we can also see that. Let us, from geometry, discover the correct answer before algebra. So, I will consider a square. All sides are equal, but I assume that this part is x, this part is 3. Okay? So if I ask you what is the area of this square, so this side and that side, this side and that side are all equal in size. But I assume that this little part of it is x units, this little part is 3 units. And I ask you what is the area of the square. If I ask you what is the area of the square, what do? You take one side. What is the length of one side? X plus 3, and then multiply it by itself or square it. If I give you the length is 5, how do you know the area? You multiply 5 by 5, 25. So this is definitely the area. But now let us calculate the area with a different technique. So I will draw a horizontal line from here. Okay. Okay, so what happens now here? But by the way, this is a little bit tricky here. Because if that is x, I can separate x here as well. Okay? And then what is left for me here is 3. Yes? And then I draw another vertical line from here. Yes? So, do you realize what is happening? So, this was x plus 3. Because this is a square, this side is also the same size. So if this is x, I separate x here. What is the leftover? It should be 3. And then if I ask you what is the area of this part, can you tell me what is the area of this part? What type? Yes, that's also a square, because this length is x, this length is x, all of them are x, so this becomes x squared. And then can you tell me what is this area? Because here is 3, here is also 3, so that is 9. So x squared plus 9 is not really far, is not a very bad guess, because it appears actually. But if you just add these two, you are ignoring these parts. That's the point, okay? So what is the area here? This is no longer a square, but it is a rectangle. This length is x, this length is 3, so this part is 3x. And the same story here. It's also 3x. So remember, if you just write x squared plus 9, it is not totally wrong, but it is not the whole story, because the whole story contains 2 more. Yes, 3x here and 3x there, which is how many x's? 6 x's. So the correct answer to this from a geometrical perspective is this. Okay? This we discovered using geometry. But of course, here we are doing algebra. Let us see what will happen if we just apply the algebra. For the algebra, how should I do that? First of all, I have to interpret power of 2. What's the meaning of power of 2? It means take the expression and multiply it by itself. That is the meaning of power 2. Okay? And now this is the lesson similar to this or similar to this. I just start multiplying. So x times x is x squared. X times 3 is 3x. That is one of those 3x's there. And another one, 3x. Another one, 3 times 9. Yes? And then happens that 3x plus 3x is 6x, and then 9. So that is the correct way of doing things. So we also learned how to raise them to natural powers, because if I ask you to do this, that's a very big difference. This you don't know what to do, so forget about the negative powers, rational powers. We just work with, in algebra, we just work with these kinds of powers that we know. Okay. Okay, so let me solve some more problems here. So what do you think if I want to multiply 3 expressions? For example, let me make it very simple first. X plus 1 multiplied by x plus 2 multiplied by x plus 3. So we want to expand and simplify this expression. If I give you 2 times 3 times 4, what is the answer to this? 24. So you decided to multiply 2 by 6, for example. So 2 by 3, it becomes 6, and then you multiply 6 to 4. Yes? You can decide to multiply 2 by 4 first, it becomes 8, and then multiply by 3. That's also acceptable. You can decide to multiply 3 by 4 first, it is 12, and then multiply by 2, 24. It doesn't matter what do you do. Here the same story. This is a number, one number as a whole. Which number we don't know, because I don't know what is the value of my variable. But that is a number. That is also a second number. That is also a third number. So if I ask you to multiply 3 numbers according to the rule that you already know, you don't need a new teacher for that. So you know that you can calculate this. Then you found the answer, then multiplied by the second one. But here it was easy. You do this in head. Here you have to write. This is not something easy that we can just do it in our head. So the point is that you need to interpret this expression exactly as that, and then you know what to do. Decide to do what? I decide to take these 2 first. So this means that I copy and paste the last part, which I am not going to touch for the time being. And then I open another pair of brackets. Inside this pair of brackets, I will write the result of this expression. which I learned what to do because I take x and multiply it here, x squared, take x multiplied there, and then take 1 multiplied here, but no one writes 1x. We just write x, which means 1x. And then 1 times 2 is 2. And this is the answer to the first part. Then I can take this and multiply it here. But I have trained myself to simplify and continue. If you just start, it is working, but I realize that these two are similar. So I prefer to simplify and then continue. So I will copy and paste this part. 2x plus 1x is 3x. And then I have 2 here. And then when it is finished and simplified, now I decide to go to the next level. To the next level means that I take this, multiplied by these two. What is the answer? x2 multiplied by x, x cubed. x2 multiplied by positive 3, positive 3x squared. This is finished. I go back here, take this one and multiply that. It becomes 3x squared. 3x multiplied by positive 3, 9x. So don't get confused. In this level, you are multiplying. At the end, you are adding. So in these kinds of problems, both multiplication and additions are involved. Okay, so 3x times that is finished. And now I go to this one. 2 times x is 2x. And 2 times 3 is just 6. And then you realize that now suddenly these two become similar terms. And these two also are similar. So what's the answer? X to the power of 3. 3x squared, I have 6x squared. And then 9x plus 2x is 11x. And then we have also 6. Okay? Okay. I think that is also to see this how it works in GeoGebra. Okay, so if I go here, I think it's better still go to cast view and then let us get rid of what we don't need. We don't need graphics here. So this is, I don't know, this is probably the instruction for expansion. I don't know, but let us see. I want to expand that. So sometimes GeoGebra is sensitive to putting this product. So let us try to see what is. I would write expand. So you see that expand. Yes, expands here, pops out, and then I would write expand expression, and then inside expression I write my expression. So that's x plus 1, and then I have x plus 2. And then I have x plus 3. I don't know if this works in that way or I have to put the product here. Yes. So when you enter, you actually get the answer that we got here. So x to the power of 3 plus 6x squared plus 11x plus 6. So remember these syntaxes because later you will have access to GeoGebra. So it is very good to know about these syntaxes. So here, I don't know, this GeoGebra is not working very consistently. So here, GeoGebra realized that you don't need to put the product sign here. But sometimes it gives, I don't know, it gives wrong impression. So anyway, so this is the thing that you need to remember, expand. Expand means write an expression which is equal to this expression, but without any pairs of brackets left. And the most simplified version. Okay? Good. Let us solve one more problem. I give you something to raise it to power 3 this time, okay? So for example, let me write this. X plus 2, and then I would write to power 3. So if you see this, don't write x to the power of 3 plus 2 to the power of 3. Be careful. If I give you 2 times x and then to power 3, you are allowed to write 2 to power 3, which is 8, multiplied by x to power of 3. This is true. Because of which rule? this rule. A times b to power n is a n b n. But we do not have such a rule that a plus b to power n is a to the n plus b to the n. This is wrong. So here you cannot write x to the power of 3 plus 2 to the power of 3. That is not the complete answer, as you will see. So what should I do then? Can you tell me? 3 times. Yeah, that's it. So this becomes x plus 2, x plus 2, x plus 2. And you just learn what to do. If you multiply a lot of numbers together, what you do, you just do them turn by turn, yes, step by step. So I will copy and paste the last one that I'm not going to touch, and I open a pair of brackets to write the result of this inside it. So the answer is x squared plus 2x plus 2x plus 4. Agree with me? X times x, x squared, x times 2, 2x, 2 times x is 2x, 2 times 2 is 4. And then what happens? I would prefer to simplify and then proceed, rather than proceeding and then simplifying. So x to the power of 2 plus 4x plus 4. I combine these two, and then I will redo the multiplication again. So this times that is x to the power of 3. X times x squared times 2 is 2x squared, plus this times that is 4x squared. 4x times 2 is 8x. 4 times x is 4x. 4 times 2 is 8. Again, I have similar terms involved, these two and these two. And finally, the answer to the problem is x to the power of 3. By the way, do you see this was not completely wrong? X to the power of 3 appears. 8 also, which is 2 to power 3, also appears there. But there are extra terms involved, yes? 2x squared plus 4x squared is 6x squared. 8x plus 4x is 12x. So if you just naively write x to the 3 plus 8, you are actually ignoring these important terms. So that's also, and then of course you see that raising polynomials, raising algebraic expressions to high powers are really boring. So if I give you 4, you have to do this 4 times. So it is really boring, yes? So this is the way that you need to know. This is just I will spend one more session on this a little bit to teach you a little bit complex problems, which is a combination. So here, either I gave you subtraction, or I gave you addition, or I gave you multiplication. But the important problems are that you have a mixture of them, okay? So that's also good to know. But I will leave the lesson now. You can rest a little bit and start working, and then I will continue the lesson tomorrow. Any questions? Okay, thank you.